everybody, let's now talk about particle in a box. This is very important topic. This might have been asked in your many exams. Particle in a box. Let's first talk about 1D box. Let's not just generalize now itself. Particle in a box. So it's a 1D box. It's a, I know it's quite hard to imagine. I'll help in that matter for you. Let's make it more clear. Let's make it more clear now. Let this be one dimensional world, what I show now. Only this line is one dimension. There are no breadths and heights here, so this is a one dimensional world. So the particle is confined to this line, and particle cannot go beyond this line. The probability is 0. The probability of finding the particle is 0 beyond this confined bound line. So we'll say that the potential here is infinity. Remember, this is a graph, energy and position graph. The potential here is infinity, and here also infinity, and the length of this line is equal to 0. X is equal to L. Say this L. Now let's write the Schrodinger's equation. Minus h cut square by 2m into d square psi by dx square plus v of x. Here one more thing, here the potential is 0 and here potential is infinity. So the particle is confined between x is equal to 0 and x is equal to L. Of x is equal to fx into psi. Psi is equal to E into psi. So this is Schrodinger's equation. Now when we solve it, we should solve the Schrodinger's equation for this part, and this part. The probability of finding the particle in this region is 0, so there is no point in writing the Schrodinger's equation of this part 1, first part. Similarly for third part, so we have to write the Schrodinger's equation for second part. Substitute all the potentials and energy values in this equation. What we get? Multiplies minus h cut square divided by 2m. M means mass of the particle. D square psi by dx squared. Potential is 0, is equal to E into psi. So it implies minus goes this, so algebra h cut square by 2m into d square phi by dx square plus E psi is equal to 0. Multiply and divide. multiply this whole equation by 2m by h cut square. It implies d square psi by dx square plus 2m e by h cut square psi is equal to 0. Since it is one-dimensional world, there is no point in writing dou and partial derivatives. So let's make this proper derivative. It is square phi by dx square plus 2m e by h cut square psi is equal to 0. This is ordinary differential equation. We can solve it. My style of solving it is slightly different. I'll show you how. You should understand the analogy here. Just imagine that I am not meaning anything I am saying. Take psi constant, I mean outside, it becomes d square by dx square. I know it's a bit of abstract method of solving the differential equation, plus 2m e by h cut square. You know what, take h cut 2m by e divided by h cut square is equal to k square. K square is equal to 0. I write it here. K square is equal to 2me divided by h cut square. What happens now? And take this as d, psi into d square plus k square is equal to 0. Now this looks like the equation, right? It looks like d square plus k square is equal to 0. So the roots of this equation, d is equal to plus or minus iota into k. The roots are imaginary. And repetitive. So for such equations, the solution is given by psi is equal to a into sine kx plus b into cos kx. Now, putting the boundary conditions. What are the boundary conditions here? At x is equal to 0, psi is equal to 0. Why? The question, why should be at x is equal to 0, psi is equal to 0? Because however, wave function is a function, means it's a graph. It may be like this, or like this, or like this, or like this, however it may be. But one thing we have to observe is here, up to here, the probability of finding the particle is 0. So there is no wave function here. Up to here, up to here, there is no wave function here. And to here, there is no wave function. And for that reason, here should also be, the wave function should be 0. Here it may take some value. 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 But at x is equal to 0, the wave function should be 0. So it happens in case at x is equal to L, at x is equal to 0 also the wave function should be 0. X is equal to 0, wave function should be 0. At x is equal to L, wave function should be 0. So let's write here 0 is equal to A sine k into 0 plus B cos 0. 0 is equal to A into 0 0 plus B. 0 is equal to 0 plus B. It implies that B is equal to 0. So this term goes to 0. So what we are left with now, psi is equal to A sine kx. Okay, we have to find A here. What we have to find A, let's put this value. At x is equal to L, psi is equal to 0. Psi is equal to 0 at x is equal to L into sine k into L. The A should take must, and it's a must for A to take any value, so A cannot be 0. Therefore sin KL should be 0. For sin KL should be 0, what is the general solution? KL is equal to where and all the sine function goes to 0. Put simply the graph here like this: 0, pi by 2, pi, 3 pi by 2, 2 pi. So KL is 0 at n pi is equal to n pi. Okay, I'll put it aside here. For reference. Okay, now sin k is equal to n pi. So no, let's put this value then. K is equal to n pi by L. Let's take this. No, these and K are equal. So psi is equal to sine K means n pi by L, n pi by L into x. To find this A, there is another surface we should do now on the stunt, perhaps. From the basic definition of wave function, psi star into psi into dx for one dimension minus infinity to infinity should be 1. By doing this, we get psi star means psi in this case a square into sine square n pi x by L into dx minus infinity to infinity. There is no point in taking minus infinity to infinity, just we are interested in x is equal to 0 to x is equal to L, and Since wave function is 0 in these regions, there is no point in taking them. So let's take uh, 0 to L. It becomes a square is equal to 1. Okay, is equal to 1. Let's put a line here first of all. Okay. What happens? A square into sine square by x by L into dx 0 to L is equal to 1. Now another circus, perhaps sine square theta into sine square x into dx. How can we write? No, not like that. Let's rewrite it like this. Cos 2 theta is equal to 1 minus 2 sine squared theta 1 minus cos 2 theta by 2 is equal to sine squared theta integrated. What will get? 1 by 2 into theta minus sine 2 theta by 2 is equal to integration of sine square theta. Put this value here. As that a square is equal to 1 by 2 into theta means x minus sine 2n pi x by L whole divided by 2 n pi by L. The limits are 0 to L. Solve it now. It implies that a square is equal to 1. Remember, a square into a square by 2 into L. Here 2n pi x becomes L, LL becomes LL cancels out. This is sine 2n pi and this becomes 0 minus 0 minus 0 minus 0 is equal to 1. So a square is equal to a square by 2 into L is equal to 1. It implies that a square is equal to 2 by L. It implies that a is equal to root 2 by L. Now put this value in this equation. What we get? This equation. I'll highlight it. This equation. Psi is equal to what we'll get? We'll get the finalized equation as follows. Psi is equal to root 2 by L sine n pi x by L. This is the wave function of the particle in a box. Now let's find out its energy. It's simple actually. It's not much of a circus as we done before. Just equate this one and this one. k is equal to k square is equal to 2m. Let's take this out. K square is equal to 2m e by h cut square is equal to n square pi square by L square. Just simplify it, we'll get energy. What happens? Take this here and this here, we get E is equal to n square pi square h cut square divided by 2m L square. For generalized formula, take En is equal to n square pi square h cut square divided by 2m L square. So this is also the important formula.